Hi, welcome back. In a previous video, we listed all the possible rational zeros of this polynomial. 2x to the fourth plus 4x to the third minus x squared minus 6x minus 3. Now I want to find all the real zeros of this function. We'll start with that. So I've got a list of possible rational zeros. Let's start testing them. So here's what I'm going to do. I'm going to take the 1 and I'm going to divide in that. So let's back up a minute. I'm going to test x equals 1 to see if it's a 0. Which means that if x equals 1 is a 0, that means that x minus 1 is a factor of the function. And if I divide x minus 1 into my polynomial, I'll get a remainder of 0. So what I'm going to do is I'm going to divide this function by this factor. This is a form that works with synthetic division. So in order to test this 0, I put the number I am testing into my box, and I carry out my synthetic division. So I bring down my 2. 1 times 2 is 2. 2 plus 4 is 6. 1 times 6 is 6. Negative 1 plus 6 is 5. 1 times 5 is 5. Negative 6 plus 5 is negative 1, and I get a remainder of negative 4. Negative 4 does not equal 0, so 1 is not a 0. Let's just keep going through my list. So now I'm going to test negative 1. Which means I am really dividing by x plus 1. So I put negative 1 in the box. I carry down my coefficients, and I carry out my division. Bring down the 2. Negative 1 times 2 is negative 2. Negative 4 minus 2 is 2. Negative 1 times 2 is negative 2. Negative 1 plus negative 2 is negative 3. Negative 1 times negative 3 is 3. Negative 6 plus 3 is negative 3. Negative 1 times negative 3 is 3. And here I have a 0. Oh, so negative 1 is a 0. And x plus 1 is a factor of my function. So what does this mean? Well, this means that my polynomial, my f of x, which is 2x to the fourth, plus 4x to the third, minus x squared minus 6x minus 3, can also be rewritten as x plus 1 times 2x to the third plus 2x squared minus 3x minus 3. This is another way of saying f of x. Okay, well, remember what we're trying to do. We're actually trying to find zeros. Finding zeros can also be said, so if we're finding zeros, that is the same thing as solve that function equals 0. Which we know by now that means that means factor. So let's talk about this guy. We could keep going through our list, but I can factor this polynomial by grouping. So let's do this. I'm going to work just inside those parentheses for a minute. And I'm going to group the first two terms together. And I'm going to group the second two terms together. Now, I got to be a little careful with that minus sign, because the minute I pull this minus sign outside of the parentheses, if I distribute it, I have to get back to what I started with, which means I change this to a positive. But now look at what I've got. I've got 2x squared times x plus 1 minus 3 times x plus 1. Those x plus 1's match. So let's write all this out. I've got x plus 1 times, I'm going to factor the 2x squared out of that first group. That leaves me x plus 1. Minus, I'm going to pull a 3 out of that second group, and that gives me an x plus 1. And now I've got an x plus 1 in both of these two terms, so I can factor that out. So what I have here really is x plus 1 times x plus 1 times 2x squared minus 3. Or x plus 1 squared times 2x squared minus 3. So what? So that means that my function, my original polynomial, can be rewritten as x plus 1 squared times 2x squared minus 3. That's a version of a factored form. But remember what we're trying to do. We're actually trying to find zeros. So this equals 0 when x plus 1 equals 0, or when 2x squared minus 3 equals 0. Which means when x equals negative 1, or when, so this would be x squared equals 3/2. So that would be the positive or negative square root of 3/2. These are my zeros. Now we can get a little more detailed because we know negative 1 is a 0 of multiplicity 2. Square root 3/2 has a multiplicity of 1. And negative square root 3/2 has a multiplicity of 1. Okay, let's take a look at our other example. So when we first started working with this guy, this x to the 4th plus x squared minus 12, I mentioned that he's quadratic in form, and so we could factor him. You may or may not remember how to do that, so let's walk through finding the zeros using the techniques we've got here. So we're going to find all the real zeros of the function x to the fourth plus x squared minus 12. And I have a list here of my possible rational zeros. Now I have a suspicion that I think I can factor this guy, and I think he might factor using a 3 and a 4. So let's just start with that. Let's test x equals 4. I might be wrong here, but let's test x equals 4. So I know from the previous example that means I put 4 in my box and I write out my coefficients, but remember I have to have every power present, so that is 1x to the fourth plus 0x to the third plus 1x squared plus 0x minus 12. And so I'm going to bring down the 1, and I multiply and add. Oh, and I can see that this isn't going to work, is it? Okay, so 4 is not going to work. And I can actually stop here, because this is not going to be 0. It's going to be a big number. That number, whatever ends up here, is not going to be 0. So 4 is not a 0. And I don't think negative 4 is going to work either. Let's go ahead and try 3. Because maybe 3 is okay. Probably not. But let's try it. Let's try 3. 1, 0, 1, 0, negative 12. Drop down the 1. 3 times 1 is 3. Add to the 0. Oh, no, that's not 0. So 3 is not a 0. Let's try 2. And that's not a 0 either. Let's try negative 2. And if this doesn't work, I'll show you the other way we do this. Because sometimes polynomials don't have any rational zeros. And that may be what we're looking at here. But we'll give this a shot, and then we'll see what we get. And maybe we'll, yeah, let's see. No, that's not any better either, is it? Okay, so let's take a look at this guy. I could keep trying. I could try 1, but I don't think that's going to work either, just based on what I'm seeing here. So I've tried the 3, and that didn't work. And I can kind of look through here and see what a negative 3 would look like, and that's not going to work. And 4 and negative 4 didn't work. And 2 and negative 2 didn't work. 6 probably isn't going to work either. So let's just take a look at my polynomial. I have x to the 4th plus x squared minus 12. And I'm trying to solve the fact that that equals 0. Now, let's go over here and think for a minute. If I had x plus x squared minus 12, I would just factor that as x minus 4 times x plus 3. Right? And I'm seeing something may have gone wrong here. Let's give this a shot. So I almost have that. I have x squared squared plus x squared minus 12 equals 0. And this will factor just exactly the same way. This, oh, wait, I see. That should be a plus and a minus. Hold on, let me fix this. I need to factor this correctly. This should be an x plus 4 and an x minus 3. There we go. So back over here to this quadratic in form. It's quadratic in form because I've got a thing squared and then that same thing. So it matches this format. If we think of x to the 4th as x squared squared, which means what I have here is x squared plus 4 times x squared minus 3 equals 0. So now let's check that. Let's check. And we're going to check it by foiling. So x squared plus 4 times x squared minus 3. First times first is x to the 4th. Plus outer times outer means minus 3x squared plus inner times inner plus last times last. Well, sure enough, that is x to the 4th plus x squared minus 12, which is what we started with, so it checks. Okay, so back over here to finding my zeros, my real zeros. We're not finding imaginary zeros. We'll do that in a minute. Well, in another section. So what this means is x squared plus 4 equals 0, or x squared minus 3 equals 0, which means, okay, so x squared is always positive, and 4 is always positive, or at least x squared is always positive as long as we're only working in the real numbers. So there are no real zeros associated with this first factor, but there are. This second factor gives rise to x is positive or negative 3. Or sorry, x is positive square root of 3. These are my only real zeros. So these would be the real zeros of my polynomial. And if I wanted to write this guy in factored form, under the real number system, his factored form would be x squared plus 4 times x plus the square root of 3 times x minus the square root of 3. And that is the factored form of my polynomial. All right, I hope this has been helpful.